Hey everybody, this is Larry. This is day 27 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. I don't know. I actually don't really care about watching programming stuff on higher res, but people have asked me about it, and I finally got the new laptop. Yay, the new MacBook Pro. And it seems like it's actually fast enough to to do this higher res thing without kind of going a little nuts. So we'll see how that goes. But also some of these things may be a little bit wonky. So let me know in the feedback in the comments. I think this webcam or whatever is higher res. I don't know if it's necessary. Now you get to see my face in a slightly higher res. But yeah, let me know. Let me know because my setup is actually new-ish for today. I kind of muck around a little bit, so let me know if anything. Yeah, just let me know any comments because I don't know if the font is a little bit too small or anything like that. But yeah, okay, let's get started. I usually start just live, so let me know what you think as you do this. Okay, what is this? Sort colors. Let's see. And this is hopefully this is not lagging anymore. I can go and it goes up. I don't know. That's what someone also was mentioning, but I don't know if that's an OBS thing or my laptop, both of which is a little bit slow. Okay, so we must solve this by using library. So okay, so this is the what is it called? Is it the Dutch flag? I think. Did I make that up? Algorithm, right? So I don't know. So this one is it's a little bit weird in a way because there is this algorithm for it, but it's not really that interesting to be honest. I mean, it actually like this problem solves this and this only, right? So or this solution solves this and this only. So it's not really that interesting per se, and that I don't know how often that this comes up, but. And I don't really remember the algorithm per se, so I usually try to think about the concepts and then try to think about how to prove them from scratch, and then like rederive it. But it's a little bit weird because I think there are a good amount of people who will memorize this, and I know that this does actually get asked on interviews. So I don't know if it's, I haven't heard it lately, but yeah. So it is what it is. Yeah, so I'm like still checking out the setup a little bit, so my apologies if it's a little bit weird. But yeah, so we're supposed to do it in place. You're supposed to be able to do it in linear time, constant space, stuff like that. So basically, here I'm going to try to think about the invariants and observations. I'm going to try to figure this out from scratch. So this may be a little bit of a longer solution. And I think last time I did this, I misimplemented, to be honest. So if that happens again, we can watch Larry debug things together and live and kind of go through it. But yeah, so I am subbing this live. So fast forward, watching it fast speed, whatever you need to do. And I'm still getting used to this laptop a little bit. So yeah, we'll see how that goes. Okay, so the one invariant is that we want to get the answers to be, 0, 0, 0, 0, 1, 0, 0, 1, 2, 2, 2, something like that at the very end, right? So we have one divider here, one divider here. There's also another one, which I guess I don't know if there. Let me look at the constraints. Okay, I mean there is also one. Oh, okay. The one pass one is the interesting part. I forgot about how to. I forgot why we. I'm not gonna lie, I forgot for a second why we needed the Dutch flag algorithm. So because the other thing that I was gonna say is you can also just use a counting sort, which is count the number of zeros, count the number of ones, count the number of twos, and then add another for loop, right? So that's gonna take 2 passes, and that's fine, right? That's not a big deal. But of course we're trying to do a little bit better this time. And I would also say that these 1 pass, 2 passes thing, make sure if you are doing it that way, don't optimize it just for no reason if you don't understand why that you need 1 or 2 passes. So the idea of between passes is that as you go through them, your computer or your whatever will pull stuff from memory and then put it back in memory and so forth. And the idea is that if you do it in 1 pass, it's a little bit more cache efficient because they're loading it chunks at a time. Where if you go for 2 pass, then you have to do it twice, right? Just loading. And in these cases, especially for for bigger arrays, the IO is going to probably dominate, especially if you're just writing for loops, or at least a linear for loop, right? So if you have 2 passes, it's going to hit the disk twice for each space. Not really true, because you also get contiguous, or adjacent spaces, but I'm hand wavy a little bit, but that's basically the reason why you want it to be 1 pass. Okay, so then now we want to sort these into this answer, right? So what can we do? Let's say we have this thing. How do we begin? I'm just working it out a little bit, because there are really only a couple of possible ways, right? So let's say you're going from left to right, which is okay. Let's say we're going from left to right, but we also have, is that still 1 pass though? If we have a pointer on the right side, right? Basically, all this does is that we have 2 pointers. Is that still 1 pass? Maybe am I doing the right algorithm? I don't know. But basically the idea is that we have the same thing that's here, right? Which is that with a pointer, everything to the left of the pointer is 0. Everything to the right of this pointer is everything to the right of this pointer is 2, and everything in the middle is unsorted. But as we keep going, we will we will sort them, right? So that's my general basic idea. But then that could be a little bit tricky, right? For example, what if you just have a bunch of 1s, or something like 1 1 1 1 0 2 1 1 1 1 1, and then you start right here, right? You start by the very end, and this is stuff that I would write out on paper, but obviously I'm trying to visualize it for you. I don't know if the font is it looks a little bit small to me, but hopefully the viewers at home can see it clearly. If not, leave a comment below as well. But yeah, so okay, so let's say we process from left to right, we see a 1. What happens? Can we just put it anywhere? Oh, I guess there's a third pointer, which is the pointer that we're actually looping through. So let's say we see this 1. What can we do? I guess we just keep the same place, right? And then we see another 1, we see another 1, we see another 1, and then we see a 0. Then what happens? Well, 0. Okay, so then that makes sense, because then that means that this 0, we want to put it on the left of this pointer. So then we just move this pointer to the right. We replace this with 0. We know that the thing to the right of this thing would be 1s, so then we can replace this with 1 by swapping. Okay, and then here we see the 2. We can just put this here, and then move the pointer here to fit that. We'll also process this 1 again. So if this was another 2, we would keep doing it as well. Okay, I think I got the idea. Hopefully, I don't know if that was very illustrative, but I was just trying to think about, okay, in different cases, I'm trying to hold an invariant, right? The invariant in these problems, or invariant in any algorithm or any computer science-y programming thing, is just something that doesn't change, right? And invariant that we try to hold here is that we have 3 pointers. Let's call this L pointer for left, let's call this right pointer for right, and C pointer for current, right? So that means that, okay, left of L will be 0s, right of R will be 2s, and then right or immediate right of L, left of C will be 1s, and then as C goes from left to right, we put into the proper bucket. Okay, I mean, I think that's fine. I think now we have enough to think. I think the only thing that's a little bit weird, maybe to me anyway, in explaining, is just that if we swap this number from the back, because these numbers are unprocessed, right? So we have to keep on updating this number until we are done. So until we get a 1, basically, or C passes right or something like that. So there's a lot of potential for off by ones, but I think we have the idea right. So yeah, we just have to be really careful and do a lot of test cases to kind of get this right. Okay, so let's just say L is equal to, I think here, one thing that you may get, or one thing that I try to think about to kind of be good about off by ones in cases like this is by really saying what this thing is pointing at, and this is pointing at actually not. So this is going to be pointing at the. Let's make it point to the L is equal to is the next space to be used. R is the next space to be used. So that means that we will swap these, and therefore we start L with 0, R is equal to n minus 1. Well, this I don't think this takes a pass, but it depends on your language, I suppose. So I'm going to say it doesn't for now, because otherwise that would make, well, it wouldn't work quite like this. And then C is equal to 0, right? So these are our indexes as we talked about. And then now we go. So while C is less than right, it may be equal to, we'll have to double check, because actually, yeah, actually it doesn't matter, because if it's equal to right, then no matter, is that true? No. So if it's a 0, okay, no, we have to, then it has to be equal to, because we're saying that R has to be the next space that's being used, and C is the cell being processed. Being processed. So if C is equal to R, that means that R is a free space and C has to be processed. So that's why we have C is equal to or less than R. Okay, and here we go. Okay, if num sub C is equal to 0, what happens? Well, we set num sub L is equal to 0. Okay, so basically if this is 0, we swap these two. Okay, I'll write it this way instead. So again, I would say this kind of takes away some of the one passness of this. So maybe I'm wrong on how I'm doing it. We'll see. But yeah, but basically we swap. Oops. And yeah, because if it's 0, let's think about this through again. So basically, let's say we have a bunch of whatever, and then there's a 0 here. We go here. What happens if there's 0? Well, we want to move this 0 to the 0 thing. So we move this 0 to here. We then have 1. But everything to the left of that was going to be 1 anyway. So I think we're good. And then we just move along then. Because everything to the right of L is already 1. So either, okay, so I think we're good here. Okay, and then we increment both of these. Okay, else if num sub C is equal to 1. And yeah, and these problems, I think, if you can break it down to enumerate all possibilities, that's fine, just keep doing it. But yeah, okay, so if C is equal to 1, what does that mean? Okay, that means that we just get to go forward, right? And L doesn't change because everything to the right of L is 1, right? And then else if num sub C is equal to 2, what does that mean? Well, we have to swap. We have to swap these for sure. And then as we said, okay, let's say we have here, and then, let's just say, because we haven't processed from C to R yet. People keep calling me. Weird. But yeah, so let's say we have something like this. What would that look like, right? Oops. So here we process the 1, things happen. So now this is a 2. Okay. So that means that we want to, if this is a 2, we want to put it on R. And R happens to be a 2, but R for all purposes is a usable space. So then we swap the 2s, and then we move this to the left. The reason why we move this to the left is because now everything to the right will be 2s, right? So okay. But then that's it for the C, because now so if this is 2 again, then that's okay because we swap it with the 0, and then we move to the left. And then now this is 0, so then now this 0 we would have to put in the front, so then we put it as 1, we put on 0, and then we can go on because we know that this is 1. So yeah, okay, I think we're okay now. I guess we don't have to return, but I guess we just I'm saying I guess a lot, I don't know why, but now we can play around with a lot of inputs. I guess that one was what I used. I mean, it's just random, but I think, yeah, let's give it a spin real quick, at least for the examples first. Maybe infinite loop, that's one thing that I worry about, but no, I don't think so, because it always makes progress, because either C gets closer to R or R gets closer to C, so we should definitely not have an infinite loop. Okay, and then maybe I'll just add like else assert force, because that should never happen, because every number should be 0, 1, or 2, but in case we do something funky. I think one thing that we can do, if I wasn't that lazy, is I would generate random cases, because these things are very easy to verify, right? Because you can just look at the result and make sure that it's sorted. That's a very easy thing. So if I was writing production code, I would just generate a lot of random tests. In fact, maybe I would do that. Hang on. Just say is what was it? Rand dot, is that a thing? Or am I thinking of another language? It's possible. I think it's like random dot int or something. Random dot rand int, maybe something like that. If not, I have to Google. Okay. Oh, rand int is the one that gives you between 2 numbers, but I always forget if it's inclusive or not. Okay, it's random.random then. Sorry, friends. I mean, like, I'm doing these live, and this time I was lazy to what you call it. Huh? So this is already between 1 and 2. Okay, I never know anymore. Wait. Yeah, so now the reason why I did this, I thought it was not inclusive. Did I mess it up last time? Okay, but anyway, yeah, we can use this to put it here. Hopefully that the spaces doesn't matter and it doesn't complain about the spaces. Otherwise, we have to write some format. Okay, but yeah, so it looks like, okay, let's get rid of this. But it looks like we're good on random cases, so I'm more confident. Let's run it again so that we get rid of the output, otherwise we might have output exceeded. Let's give it a submit. Oh, I did it. Well, I did it in Java a year and a half ago, and time flies. 575. So yeah, so so I think this is the Dutch. If I'm wrong, please leave it in the comments. I think this is the Dutch flag algorithm, but I don't actually remember it. I just remember the name. But I guess the core idea is that these dividers, and I think people do use this to kind of figure out how to describe invariants, right? And kind of like, you look at this code and it looks obvious and it looks easy, but the kind of idea and the concept that we talked about, you have to figure it out and just understand it, right? And as you can see, this is linear. I guess this is one pass, because I don't know, but these things are always a little bit weird, like I said, because we do swaps and stuff like that. Yeah, I don't know. I mean, like, it's one pass in concept, but in terms of like actual hitting memory usage, it's unless it's for a small array where everything fits in a very small cache, a very close cache, like it's weird anyway, right? Anyway, that's all I have with this one. Yeah, I mean, I would say that I like this new computer so far. It's basically the same computer that I had, except for it's faster, and the fan doesn't blow right now, because usually as soon as I'm recording videos, the fan, it goes crazy. So I don't know. So it's not right now, which I'm really happy about. We'll see how that goes. But yeah, but so far I'm happy. Anyway, stay good, stay healthy, to good mental health. I'll see y'all later, and have a great rest of the week. Bye bye.